Welcome to this lecture at the beginning of Unit 4 in CSC-200. I'm going to be going through a set of slides here with you. These slides are in a traditional format, which I mean by that they have a lot of words on them. I have put some illustrations in here too. It's no longer my preference to put words like this on the screen, but instead to write them up and speak them. But in this case, the words will sum up some of the important topics, and I will make available to you the slides in a condensed format. You'll see some of these are animated, and there's no real reason for me to give you the whole animation on paper. If you want to have them for review, I'll be giving you a subset of these that make more sense for print purposes. What we're going to be taking a look at today is the Internet from 2 points of view. First of all, in general, what does it do? How do you interact with computers elsewhere on the Internet? And then we're going to take a closer look at the way that the Internet arranges communication, that is, arranges the communication of information between 2 points that want to communicate. And we're going to see there's a tremendous difference in the way that the Internet was engineered over the way that the traditional telephone system was engineered. Now, we're not talking about the telephone system necessarily as something that connects old instruments sitting on your desk that you dial up somebody else. We all know we have cell phones these days and they communicate differently. However, unseen by almost everybody is the fact that the traditional telephone infrastructure, that is the stations that were set up every couple of miles to serve households, called central offices, where a few thousand telephones are wire connected to a central office, which then is connected to other central offices, and it forms a large network. We'll see how the traditional idea of connecting one person who wanted to speak with another person is far different than the way that the Internet handles that, and we'll talk about the reasons why. So first of all, what's the Internet? Well, it's a pipeline that connects computers, and physically it's composed of the things you see here in blue. That is wire telephone lines, fiber optic, which is a little glass fiber that transmits pulses of light, and other forms of high-speed communication links, including satellite and undersea cables, and anything else that can carry an electronic signal from one place to another. As I just mentioned, it's based on a different signal routing technology. And routing and switching we're going to use synonymously. When we talk about switching, that is, how does the network hook you up with a specific place that has the information that you want, or some other person that you're speaking to. Even, by the way, with cell phones, we're relying on this because your cell phone doesn't talk directly to somebody else's cell phone. It's not like a walkie-talkie where you have an instrument that's talking directly to somebody else's little handheld device. Your cell phone connects over a short distance to the traditional telephone system. And that's what gets the signal almost the entire distance to the person that you're calling. The final connection between whatever cell tower is close to them and their phone is made with a wireless method with radio frequencies. But most of your conversation actually traverses a traditional kind of a communication system. So the system that was invented in 1879 by Alexander Graham Bell, his invention led to the development of a communication network that spans the United States and the world. That traditional network is still in place. It's been improved over time, and it works differently now. But its switching mechanism is still in place, and it still has the philosophy that we're going to talk about in a minute. That is still very relevant to the Internet. Okay, what's the World Wide Web? It's not really synonymous with the Internet. It's one of the things the Internet handles. So the Internet is that physical creation that can transport signals. One type of signal that we've all agreed upon will act in a certain way is what underlies the World Wide Web. What that really comes down to is this term here, hypertext markup language, and images in this or some other form. This is what's conveyed one way or another from one computer to another in order for your screen to light up on the Internet. The thing on your machine that receives this HTML and makes sense of it and paints the screen for you is called a browser. And you're familiar with the fact that we have several different browsers in existence. They're software. The first of them, Netscape, was put together in the early 90s, the internet had already been around for about 20 years at that point as a means of conveying these sorts of signals from one computer to another. Prior to the development of browsers, what was conveyed was simply text. It was just messages between academic institutions and government research organizations. When browsers came along, that's what opened up the internet to everybody else. And you could say that browsers and the web really go together. Because with the development of HTML as a means of sending information to a browser so that it could recreate the intended screen, that's when the web really started. And then the web has its own infrastructure of connecting people with one another, a way of establishing who wants to talk with who, which was also added to the internet. Let's take a look here at an animated picture. Suppose we have somebody in one place, Kalamazoo, Michigan, and they want to obtain some information from a computer that's located in Timbuctu, Indiana. Perhaps these places exist, perhaps not. I'm not so sure about Timbuctu. I know Kalamazoo is there in Michigan. So there's stuff, and this stuff is really HTML and pictures. So what's going to happen? How does the machine in Michigan get the stuff? Well, you might think the stuff is just sent down to the computer in Kalamazoo, but in fact that computer has to ask for it. So what happens here is, this occurs in order to send a picture down to the computer in Kalamazoo. And that picture of bananas that you see here, I've called that stuff plus bananas, because the stuff I'm saying is really HTML, and the image is conveyed by a digital picture that can be scaled as to size at the receiving end. So here's the questions that come up from that very simple description of what the internet is. How is this stuff defined? That is, what does HTML look like? And how does the computer in Kalamazoo figure out where this stuff is, and how does it ask for it? Because the machine at the other end doesn't know that somebody in Kalamazoo wants it. It's not sitting there like a radio station broadcasting this stuff. You have to ask it to send it. That's why you put a URL on the address line of your browser. That sends a message to the place that you just named, and it says, send me the beginning of your stuff. And the beginning of your stuff is usually named a specific way, in a specific place, on that computer system, acting as what's called a web server. So when you ask for that, typically it's the high-level screen, a menu screen that has other selections you can make on it. When you ask for that, for example, when you put in www.google.com, you're sending a message to Google's server, and it's coming back with its initial screen, which is where you're going to put something that you search for, the keywords that you're looking for. So question number 3, how does the computer in Timbuctu, that's the sending location, provide this stuff? And how does the PC in Kalamazoo actually understand the computer? It might be a completely different kind of computer. You're already familiar with the fact that some of us have PCs, some of us have Macs, but there are other types of systems in the world too. There's other software that could run on a PC. Linux is one of them, a different operating system, and even others. And the web servers are not necessarily either Macs or PCs. They might be Linux machines or Unix machines, or even IBM mainframes, or somebody else's type of computer. So how do these computers really understand one another? And then, of course, how do you say bananas to a computer? Well, here's what happened. The stuff we're talking about is instructions on how to format the computer screen. And we've all agreed that hypertext markup language is the way that that's going to happen. Now, that agreement is absolutely necessary. If we were all talking different languages, we couldn't communicate with each other. But this is a standard that was developed in the early 90s and has been refined ever since. And this standard is what makes it possible for one computer of a certain manufacturer to talk to another computer. And it is conceivable that you might have a PC acting as a web server and a Mac at the other end asking for information, or vice versa. It doesn't really matter, because we've all standardized on this way of communicating over the web. Every computer that gets onto the internet has a unique address. It's called the IP address, the Internet Protocol address. That address consists at the present time of 4 groups of up to 3 number digits. Now there's dots in between just to make it easy for us to write those numbers out. And they have specific meanings, these groupings of 3. Now that accounts for billions and billions of numbers, but Currently, the internet is running out of addresses. It has grown so much. The last of the addresses, in fact, in 2011 was just allocated to providers that assign them to subscribers. And so changes are in the works to expand that address will mean everybody on the internet is going to have to adapt to it. Most users will just see a different browser in use. When updated to a browser will take care of it, but there'll be a lot of other changes behind the scenes. For the moment, though, this is the IP address, and your machine has one. You can see it when you're connected to the internet with a command that you can issue. It's just a bunch of numbers. You have no control over it. It's assigned to you by the way that you're connected to the internet. So here's a machine sitting in Timbuctu that has this number 201.61.186.227. The internet address resolution ultimately has to get to that number in order to connect to that computer. But there's a nice feature that was built into the internet, and it's called the Uniform Resource Locator, the URL. When somebody makes up one of those names, like google.com, or I have embryona.com, which is where I store my stuff, it's just a name that I cooked up, and I registered it. Registration means that I've gone to somebody who is empowered, that is one of these registrars on the internet, and I've got to pay them a little money to do this. It's a licensing fee, more or less. They register my intended URL, and they tie it to a number that I give them from wherever I get my computer support, and that's what supplies to me the address that you're looking at here, for example, is 201.61.186.227. So whoever I choose to pay to host my website, that is to host my HTML, their number that's already been assigned to them is what I associate with my URL. When you put my URL into your address, your browser's address line, what happens is there's a number of high-powered servers that are connected on the internet that have the lookup tables so that that name can be looked up, and the corresponding 12-digit number as to the address of the computer that hosts that is made known, and then the message is sent to that computer by that number. So what happens here actually is that the computer at this distant location is sending HTML to the requesting computer. For me to get it, I have to have told it to send me that stuff. So I have to originate a message. When I put that site's URL on my address line in my browser, that address, that URL gets resolved to a number address, and the message is conveyed from my computer through the internet to that computer to say, send me the stuff. That is, send me your high-level index page. And in response to that, at the left side of the screen where you see the machine in Timbuctu, its web server will respond to that by sending the stuff to the address from which that request came. In other words, in the lower right corner, you see 192.44, 122.46. That looks pretty much like a DePaul address someplace. So the DePaul computer is requesting something from this Timbuctu computer. And in response to that, the machine in Timbuctu, which happens to run Unix, but it certainly understands HTML, sends the stuff through the internet down to the machine that requested it. All of the communication occurs with ASCII codes, that is plain text. Everybody uses the same coding scheme for ASCII as well. So that's another point of standardization that makes it possible for this kind of communication to occur. How do you say bananas to a PC? You're already familiar with still images. You realize that a JPEG is really instructions on how to paint the picture on the screen. That's all it really is. When the JPEG is made, the image that's focused on the sensor that's going to convert the light into electrical signals breaks down the picture into a bunch of little dots, and the color intensities at each dot, red, green, and blue, are measured, and those values are what's stored in the JPEG. So when that JPEG is sent from one machine to another, what's really being sent is the information for the receiving machine to paint that picture on the screen by coloring each of those small dots with the color intensities that are indicated in the JPEG. Now because of that, because it's just an instruction to paint the screen, what happens is the screen can be painted with that image in any size. It's simply a matter of scaling. I'll show you here how the very same JPEG sent from a sending computer to a receiving computer, the receiving computer can process the HTML, which says at what scale to paint the JPEG that I've sent. And that's how the very same image is sent and perhaps repeated in multiple sizes, as you see here. The thing about it is, though, we do want to minimize the amount of information sent from the sending computer to the receiving computer. It makes no sense to send a large image and then to scale it down within the HTML to make the browser work a little harder and make this large image into a small one. The problems are those two things. The browser works a little harder, but that's not the main issue. The main issue is conveying that large-sized JPEG through the internet and perhaps a slow connection at the receiving end, and then reducing it in terms of its presentation size. It would be much better to photographically edit the image at the sending end when the HTML was first put together by a web designer and scale it down at that point so it physically becomes the size that you want to present it. And then scaling isn't necessary on the receiving end, and the file is much smaller, so the screen may come up faster at the receiving end.
What does HTML look like? Well, actually, it's rather simple to see that. I'll just tune into a web page that I'm very well familiar with. This is where I park my material, a place that is hosted on the web someplace out in Arizona. This is the home page for a site that I used to use for courses like this, and I still do put things out there. There's a little video I arranged to have start playing immediately. Not that it's very profound, just as a means of introducing things. Let's take a look at a page that supports another course that I do here. The only reason I'd like to show you this is I know what the HTML looks like, and I'm going to show you right now. If you have in your browser something that says View Source, that's going to present as ASCII characters what's currently painting this screen. So let me do that. And here you can see what the HTML looks like. Now, it's not being presented in a way that I can change it. I'm just showing you this as an example to let you see what it is that HTML looks like that the browser interprets. What's happening here is everything that you see like this with these pointy brackets at either end are called tags. HTML defines what those tags are. Those tags can have various things that are mentioned in them. And here we have a tag for a reference to some other page. This is how the buttons at the left side of this screen are arranged so that when I click on one of those buttons, the one that says Chapter 1, for example, will branch to this page. This page has been formed either by me coding things in a text editor, like a word processor, but without any formatting, or in an editor that makes it easier, gives me a what I do is what I get kind of a way to format things, much like Word does for documents. So this is fairly simple looking HTML. It's simple looking because I followed a simple pattern here to arrive at a site that looks like this. And now you see the action of having selected that button. Here, if I viewed this source, I would see something similar, but the content is different. And the links here to other places on the web are different. You can see here, though, I've used an article in Wikipedia, and my HTML is referring to somebody else's website. That's entirely possible. Here, I wanted to get this definition. I had found a location of it, and that's how I linked to it. The appearance, however, when I go to these things, you may think that it's actually at my website because I'm clicking on this and that other place comes up. But what's really happened here is the web acts like a giant repository of information, and when people put various sets of HTML out there accessible on the web, one way to get to them is to put this address here in the browser's line, but the other way to get to it, which is much more common with these menu-based systems, is to encode that here, and you see at the bottom of this screen, I can't move the cursor there because it will go away, but at the bottom of the screen you see this web address that I'm going to branch to when I click on this link. By convention, links are underlined. They don't actually always have to be, but it's a very good convention that anything underlined is a hyperlink that you can click to. What you're looking at here, by the way, is the website that I set up with a lot of research on where this information comes from to make more or less an online textbook. Similar to what you're receiving in PDF form, this was an earlier attempt at it to be able to replace a published textbook with material on the web. And in fact, I'm going to go back to the home page here. There are other items I've put out here in exactly this same way in order to provide information in a handy way to students in one or another class. This, for example, is a very profusely illustrated website that has an awful lot of interesting things at it. I'll be revising this in the near future. So that's an illustration of what HTML looks like, and we'll be working with that in the near future on some of your projects for Unit 4.